Hey guys, welcome back. So in this today's session, we are going to see about the one more random access protocol, that is CSMA. We will see that what is actual meaning of the CSMA, then why we require CSMA protocol, right? So then we'll compare CSMA protocol with the Aloha protocol. So what is the disadvantage with the Aloha? We are going to see, right? So if you understand my previous class, you should notice one point is that, so if you have the 4 stations, something S1, S2, S3, S4 means, so in case of the slotted Aloha or pure Aloha protocol, when our station has the frame to send, right, so immediately it is sending the frame. It is not concerned about or bother about the remaining the station, whether those are sending also, it won't bother. The moment it has the frame, directly it is sending the frame. Even the collision is occur also, it is not caring. So now what we are going to do is that we are going to implement something advanced mechanism, that is what we call as the carrier sense multiple access protocol. So first we will try to understand what is the meaning of the carrier, what is the meaning of the sense, what is the meaning of the multiple access. The meaning of the multiple access means, here we have the single communication channel. This can be used by what? Multiple stations. That is what we called as the multiple people are accessing, nothing but the multiple stations are accessing. Now what is the meaning of the carrier? So carrier meaning is nothing but this channel or link we called as the carrier. Now what is the meaning of the sensing, right? So sensing means, so see that if you observe here, each station that is connected to the channel or carrier, right? So this is connected, S3 is connected, S4 is connected. Now what we are going to do is to minimize the chance of collision and therefore increase the performance, the CSMA method was developed, right? So the chance of collision can be reduced if station sends the medium before trying to use it. So what is the meaning of this one is, somehow each station is connected to the channel. So here we will be having the some connection for S1, S2, S3, S4. Now what I am going to do is, the moment if I have the frame to send from the one station to the another station, so if I have the frame, I am not going to send it immediately. Before going to send the frame, first I am going to perform the sensing operation. So sense means I am going to check either this particular point of the time whether the channel is ideal or busy. Ideal means there is no some other packet coming towards this direction at this place, then we called as the ideal. If some packets, if some frames are coming to this here, now it is called as the busy. If it is busy, what we are going to do means, we will postpone our frame to send from the particular station to the some other station, right? So it means that the carrier we are going to sensing, right? So see that you will be understanding here. CSMA requires the each station first listen to the medium. It has to listen to the medium or check the station of the medium before sending. In other words, CSMA is based on the principle of sense before transmit or listen before talk. It means that if you have the frame, don't send it immediately. First you check the channel, right? If it is ideal, then only you transmit the frame. If it is busy, you wait for some time. Once it is get free, then only you transmit here. That is the basic principles of the carrier sense multiple access protocol. So then one more important point you need to be remember if you want to understand the further concept. So it is sensing, right? So at this location only it is sensing. S1 will sense at this location, S2 will sense at this location, S3 will sense here, S4 will sense here. It means that suppose for example, if some frame is coming here, so that it can able to sense, it will postpone it sending of this particular frame. Suppose for example, this is important guys. Suppose here frame which is already started to send by the S4. So for example, let you consider that S4 is assumed that channel is channel is free or ideal, so it is sending the frame, right? But here what S1 is doing means, S1 also having some frame, right? It has to send from the, let us say S1 to S4, right? So from station 1 to station 4, this frame has to send. Remember that this frame is already started at the S4. After some time it will reach to the S1, let it be something like this. Now S1 also trying to send the frame from S1 to S4. So first what is the procedure of in carrier sense CSMA technique? First it is going to check the channel, right? So at this point of time it will find it is ideal. Why it is ideal means, here the frame we have, See, one point to be remember is that at this point of time only it can able to sense. It cannot able to sense what is here, what is here. That is the point you have to remember. That is very, very important. So at this point of time now it will sense, it will find it is ideal, so that it is sending the frame. But why means it don't know what about S3, what about S4, what about S2. So it does not know what is happening here. It will sense only this part only. Now in this case we will be having the moment when this frame coming to here, sometime this frame coming to here in the single channel, we will be having the collision. One point to be clearly understand is that the each station can sense only at this particular location only. If it is ideal, it will transmit the frame. If it is busy, it will wait for some time. It means that after you are sensing the particular channel, it does mean that CSMA can reduce the possibility of the collision, but it cannot eliminate it. Why it cannot eliminate it? At this point of time only it will sense, but here it cannot sense, here it cannot sense, here it cannot sense. That is the problem here, right? This point is very, very important to remember. Now we will see that in CSMA method what is called as the vulnerable time. So vulnerable time is something we called as when one frame is sitting with the another frame, that is what we called as the collision, right? So what is the vulnerable time? In which place, I mean in which time period the collision will be occur, that is what we are referring in terms of the vulnerable time. Now for example, see that the moment if you are sending the frame at S1 from the S1 to S4, something like this. The same way we are sending the frame from the S4 to the S1, something like this. Now see that at this point of time the link is ideal, right, as per the CSMA method. So at this point of it will send the link, it is also ideal, right? Now it will start send the frame, it will start send the frame. So it means that collision can be occurred here, or collision will be occurred here, or here, or here. That is depends upon the time period, how it is traveling, what is the time here. So now see that what is the vulnerable time means. So first we need to understand what is the meaning of the propagation time. Propagation time means the amount of the time where frame will be reached from the transmitter to the receiver is called as the propagation time, nothing but the TP, from the transmitter to the receiver. Now see that collision can be occurred in anywhere, right? It may be occurred here, it may be occurred here, it may be occurred here, right? So the vulnerable time for the CSMA is the TP, propagation time period. So the time is needed for the signal to propagate from one end of the medium to the other, right? So when a station sends a frame and any other station try to send the frame during this time, a collision will result, right? This is the important point. What is the vulnerable time period? It is the propagation time period, nothing but the TP. Now as we are discussing that if channel is busy, we have to do something. If channel is ideal, we have to do something, right? So that we have to implement the practically. So for that in CSMA we have the three methods, right? So those methods we called as the persistence method. So that persistence method will address the what should a station do if the channel is busy, right? So what should a station do if the channel is ideal? Three methods have been given to answer this question. First one is called as the one persistent method, second one is called as the non-persistent method, another one is called as the P persistence method, right? So what these three will tell us is that if channel is busy, in this case what is going to happen? If channel is ideal, in this case what is it is going to happen, and what it will do, that is what we are going to study here, right? So first we will try to see that what is the operation of the one persistent method, right? Now as we discussed that first thing is that we have to sense the channel, right, before sending the frame, right? First we need to find out whether the channel is free or not. We need to send at this particular point of time period. Now see that this is a simple and straightforward, right? So see that first we'll try to read the statement. In this method, after the station find the line is ideal, it sends its frame immediately with the probability of 1. So that is what we called as the one persistent. So it thinks that whenever the station is ideal, so it can able to send the frame. So it will think that whatever the frame I am sending, that will reach to the destination successfully without the collision. That is the meaning of the with probability 1. Right? So this method has the highest chance of the collision. We will see why it is having the highest chance of the collision, because two or more stations may find line ideal and send their frames immediately. Now for example, see that now what it is going to do is it is going to sense the channel. Now see that it is finding the busy, right? Now at the next second itself, again it is sensing the channel. If it is busy also, next second it is sensing the channel. Next second, next second, next seconds, immediately, continuously it is sensing the channel. The moment whenever it gets the free, it is not thinking. So here it is finding that ideal, but there may be frame from here, or there may be frame from here, right? It can sense only here, it cannot able to sense here and here and here, right? Now what it is doing means, the moment it looks like something, if it is ideal or free, it is sending the frame with the probability of what? 1, with the maximum probability with the 1. So if it is sending, you just try to understand, collision will occur or not. It is sensing only at this point of time. There may be chance of coming frame from the here, anywhere, right? Now what will be happen? The collision will obviously occur. It means that it is continuously sensing the channel. Whenever it gets the free or ideal, the next seconds, within a fraction of second, it is sending the frame. So here we have the highest chance of the collision if you are using something called as the one persistence method, right? Why? The moment you are finding the channel is ideal without caring, so you cannot do that, right? You cannot find out in real time. So it is sending the frame, so that if other stations also start sending the frame, means the collision will be occur. So in this method there will be highest chance of collision, right? Now see that, we will see that what is the flow chart. First it is going to check the channel it is going to check, right? So if it is ideal, what it can do, continuously it is checking, right? If whenever it finds the channel is ideal, it is going to send the frame, right? So for example, if it is busy, then what it is doing, again it is checking the channel. Once if it is finding the busy, the next second it is checking the channel. If it is busy, again busy, continuously it is checking, so that whenever it becomes the ideal, it is sending the frame. That is what we called as the one persistent method. So here remember that there will be highest chance of the collision. So this one kind of method, so we are going to add some extra mechanism. So in the next method, that is what we called as the non-persistent method. We will see that what is the meaning of the non-persistence method. See that in the non-persistent method, a station that has a frame to sends the line. Obviously it has to sense in case of the CSMA method. If the line is ideal, it sends immediately, right? If the line is not ideal, it waits random amount of the time period. Remember, if line is ideal, it will send the frame, but if the line is not ideal or channel is not ideal, it waits for the random amount of the time period and then sends the line again. So the non-persistent approaches reduce the chance of the collision, because it is unlikely that two or more stations will wait the same amount of the time and retry to send the simultaneously. First we will try to understand what is the meaning of the statement. So first what we are going to do is, if I want to send the information from the station 1, first I am going to send this particular channel, right? So if it is busy, what I'm going to do is, next second itself I am not going to check whether channel is ideal or not, right? If the medium is busy or channel is busy, now what we are going to do is, we are waiting for some period of the time period, right? So after some time period, again we are checking the channel, right? So if channel is something busy, again we are waiting for the some more time period, right? So if here channel is ideal or free, so if it is find ideal, we are sending the information, right? Now see that here what we are going to do is, unlike one persistent method, it is continuously checking the channel free. Once if it is ideal, then it is sending the information. But in case of the non-persistent method, it is also something like one persistent method only. First it will check the channel, sense the channel. If channel is ideal, so it can transmit the data. It won't bother about the S4, S3, S2. But even though if you try to bother also, it cannot find out the solution, right? Now if busy means, in case of one persistence, again it is continuously checking. But in case of the non-persistent method, it won't perform something like this. It will wait for some random amount of the time period. After the time period is completed, again it will perform the channel sensing. Here if it is finding again busy, it will wait for one more time period, random time period, then it will sense the channel. If it is free, then only it will send the information. Now see that, so it is going to sense the channel, right? So if the channel is ideal, what we can do, we can send the information. Here also collision will be occur, no way, here also collision will be occur, but it is something better compared than the one persistent methods, right? If the channel is busy, what we have to do? We are waiting for the random amount of the time period. Then again we are going to sense the channel. If the channel is ideal, we can transmit the data. Again, after waiting for some more time also, if the channel look like busy, again we need to wait for the some more random amount of the time period. Once it is completed, again we are sensing the channel. Now see that you might be having the doubt. So how it is better than the one persistent CME? Suppose for example, see that, right? So if it is busy something, right? So I am going to wait how much of time period? Let it be I am going to wait for the 3 minutes, right? So here if it is find the ideal, so at the first minute it is going to send the transmission. Now what will be happen means before 3 minutes it will complete the transmission. So just for example, right, at start the transmission S4 is at the first minutes, before completion of the 3 minutes it reaches to here. Now this guy will send what? After 3 minutes it will find ideal, so it will send the data, but here we don't have any data from the S4 to send again. This is some kind of example. So that's why it is better than the one persistent method. This is also collision will occur. Now what is the one of the disadvantage of this one is, however, this method reduces the efficiency of the network because the medium remains ideal when there may be station with frame to send. And what is the meaning of this one is, suppose S1 when it is finding the busy, let it be it is waiting for the 5 minutes time periods, that random amount of the time period. So for example, S4 also finding the channel is ideal, it is going to wait for the 5 minutes also. Now see that in between 0 to 5 minutes, right? So nothing data we are going to transfer in the communication medium. We are not sending any data. It means that we are wasting of the 5 minutes of the time period, something like this. This you need to relate with this meaning, right? So because we are waiting the random amount of the time period means, right? So that because the medium remains ideal, right? At the 5 minutes time period, up to 5 minutes time period, there may be station with frame to send also, it cannot send. That is the drawback of this P persistent method. So then one more method is what? Sorry, non-persistent method. The final method we have the P persistent method. Now see that first point you need to remember that it is used if the channel has the time slot, right? So each time will be divided into the multiple time slot. Remember, each slot duration is equal to greater than the maximum propagation time. What is the maximum propagation time? The amount of the time which will take to send the frame from the transmitter to the receiver is nothing but the propagation time, right? So each time interval will be said that it is going to have the propagation time greater than. The P persistent approach combines the advantage of the others two strategies, right? So in case of one persistence we have continuously monitoring. So in other method non-persistence we have something called as the waiting time period. So if you are waiting for the more time, then channel remains ideal. So if anybody wants to send also, they are not sending the frame. That is what the limitation of the non-persistent method, right? So this P persistent method is the combination of the what? The two strategies, right? It reduces the chances of the collision. It cannot able to, I mean 100% it can able to reduce the chances of the collision, and it will improve the efficiency compared to those two persistent method, right? Now we will see that what is the steps it is going to perform, right? So it consists of the one persistent as well as the non-persistent modes combined together. Each node observes the channel in the one persistent mode. First what it is going to do is, it is going to use the one persistent method. As we discussed in the one persistent method, it is continuously monitoring the channel even though if it is busy, right? That point you have to remember. So first it is going to perform the one persistent mode, and if the channel is ideal, it send the frame with the probability of the P. If something here the channel is ideal, it send it the frame with the probability of the P. If the data is not transferred, the frame restarts with the following time slot after waiting of the 1 minus P probability, nothing but the random period of the amount of time period. And it means that here for example, if there this particular time period, the particular probability outcome is there. Suppose for example, here if channel is something busy, again it will not go here, right? So it will restart the timer from this time slot. That is the meaning of this one. Now we will see that procedure. What is going to happening means, with the probability of P, the station sends its frame. Ante first we are going to use the one persistent method, right? If the channel is busy, again we are going to sends continuously as per the one persistent method. Once if the channel is, you are finding the ideal, right? Now here we have the something called as the probability outcome. So what is the probability outcome means, each time period will be divided into the time slot. Each time slot will be having the duration equal or greater than the propagation time period. It means that if the probability outcome, if these all time slots completed, then station can transmit the frame. It is nothing but if probability is something greater than or equal to p, less than or equal to p, the station can transmit, right? So if the probability outcome, something here your frame is here in this time slot, right? So now what it will do means, it will not send the frame immediately, it will wait for the some time slot, right? So again it will check here in the next time tab. If it is busy means it is used to back up the procedure. If this time slot also the channel is ideal means, now what will be going to means, it is executing the probability outcome. Again if it is completed this one, it can transmit. If not completed, suppose if the frame is still here in the second slot, again it will going to sense the channel. If it is ideal, now again it is going to check the probability outcome. If it is final one, then it is going to station can be transmitted. See that here the probability outcome does not allow transmission. So even though it is waiting for the time slot, again it is going to check the channel. If it is ideal, now it is going to check this probability of the outcome. It is lesser than p, station can transmit. If greater than p, it is waiting for the beginning of the next time slot. So see that here you can see that with the probability of p, the station sends its frame. With the probability of 1 minus p, the station waits for the beginning of the next time slot. If you are here, then this is nothing but your beginning of the time slot. If you are here, this is nothing but your beginning of the next time slot. Here also if the line is ideal, it is going to check the probability outcome, right? So next, if the probability outcome is lesser than p, station can transmit. If greater than, again it will wait for the next time slot. Something it is, if it is completed, that is the lesser than probability, right? If the line is busy, it acts to the collision has occurred, something is happened, and it use the backup procedure. As we explained in the Aloha protocol, what is the backup procedure, that procedure it is going to use here, right? I hope you understand. Thank you.